So this is securing your AI workloads, which is really a disguise over securing your Azure workloads. But this is particularly going to focus a little bit on some AI deployments towards the end of that as well. I'm sure you are all involved in some sort of AI project and probably want to know how to make sure that people don't get your data. And so that's what we're looking at. Ultimately, this is me. I'm Brian. I'm a Microsoft MVP and a Microsoft certified trainer. So I have a number of certifications around Azure just because it behooves me to do so, since I can therefore train on those. So if you have any questions about Azure certifications, you can come talk to me. I also wrote a couple of books with A-Press, and I got to meet my editor for the first time today. He's here. He also went to Iowa State, so that was the coolest thing I found out today so far. And is Practical Entity Framework 10 is my latest book, and that one is available today if you would like to have that. So that's me. So what we're going to talk about today, I just want to set some expectations for you. We are going to talk about a couple of things with AI, and we're going to go on a little bit of a whirlwind tour. This is a very short time period to go over all the stuff I would like to present to you. So there is a blog post type of thing out there where you can get the slides. I will be adding to that likely in the future. I have to make this into an hour-and-a-half talk for later this year, where I'll go deeper with some of the details, as well as I'm trying to figure out and iron out how much bicep I can release for free to the world, and such and so on and so forth, without violating any security or privacy constraints that other people might be mad if I did that. So most of what we're going to talk about today is going to circle around to the secure Azure side of things. How do you do network deployments, how you get that working, some different gotchas you're going to run into when you're trying to actually deploy to a private network, the different types of private things you can use to make your stuff secure. Essentially, we're going to also kind of go along with CI/CD deployments with that as well. We are not going to talk about strategies for securing your AI coding with agents. So we'll talk about that being a problem briefly at the start, but we are not going to go deep into how to solve it. And we are not going to talk about how to prevent your people from doing bad things. So that's going to be something for a different talk. But let's go ahead and start and find out why those are important with Oh My AI. So I'm sure you've all heard these, but Samsung had a little bit of their source code get leaked into ChatGPT. So I'm sure the employees didn't mean to do that, and I'm not really sure it was entirely their fault. And what I like to focus on a little bit about this first part is, it's really our job as the team, either being on the network or the security or the development side or the DevOps team, whatever you are, to make sure that we're helping to prevent our people from doing things they shouldn't do. So one thing I will say, this isn't technically a sales pitch for Azure, but I do use Azure a lot as an Azure MVP. And I will tell you that if you use Azure OpenAI, it is private. It will not be used to train their models. Your data is set up to be enterprise ready by default through that. So you can be a little bit rest assured. The other benefit you get is that it's your residency. You can put the data where you want. So you're not actually just buying a subscription to something and hoping they don't use your data to train. Has anybody heard about No Takesies Backsies? The chatbot that gave away a truck, a 2024 Chevy Silverado for $1. So apparently, the AI agent said, that's a deal, it's legally binding offer, no takesies backsies. So we don't want that to happen to us. And the Air Canada chatbot that issued a refund, which was upheld in court. So even though the policy was wrong when the chatbot quoted it, they ended up getting their refund after legal action. So interesting stuff that we have to be aware of. AI said it, so it must be true, right? How would you feel if you decided to see what the best book you could read this summer is, and you see a brand new book by your author that's your favorite author that you've never read, and you're like, yes, I'm so excited, only to find out it wasn't a real book. So that went out into the world last summer on the top books to read, or these lawyers using ChatGPT to quote legal cases that didn't exist. So AI hallucinations are a thing. So again, this is something that we can look at Azure Search to help us to prevent hallucinations a little bit as well. I'm not going to say that we can completely eliminate them, but we can certainly get closer when we ground our data. And now we have these agent things, and we have ClaudeBot or whatever else you're using to do some sort of automated chat agent that's going to do stuff for you overnight and magically make your life so much better. But they're just, as they said here, one prompt injection away from a disaster. And Pocket OS had a bad week, huh? Did you guys hear about that? Deleted their entire database, all the backups. So apparently there was an API key in a file that the agent wasn't even supposed to have access to, but it decided it needed to elevate its privileges to fix the problem by deleting a database, and did it anyway, and then profusely apologized that it didn't ask permission like the rule told it was supposed to. So if we can't trust our rules for our agents, we're in a big trouble. And so that's something else. Now again, this talk isn't a lot about that, but that is something we need to keep in mind as we develop AI solutions, especially as we automate them. So AI search, of course, can help us reduce some hallucinations, but it's not the end all. But what's really nice about AI search in Azure is you can ask the question, it goes out and it goes against the documents that you've already prefabricated into search for the vector search, the embeddings, all the things you need to get the answers that most likely make sense. The top chunks come back, the model voice answers from those chunks, and then ultimately, again, that data isolation is your responsibility and under your control. So there's a couple of different Azure search patterns we'll talk about at the end for those of you who are developers in the room and are interested in that. But first, let's get into the meat of what we're trying to accomplish today. So the first thing is, we've probably all done this, especially if we were just messing around. We created a working solution in Azure. We maybe had a key vault, maybe had a SQL database, we probably had some sort of storage account. And for those of you who aren't developers in the room, you may not be aware of this, maybe you are. And for those of you who are developers, you're certainly aware of this. Every resource at Azure typically has some sort of thing called a connection string that I can use to connect to that database as long as I have it, or that storage account. And if it's public and I have those keys or that connection, I can do it from where I need to, as long as there's no additional firewall rules in place to prevent things like specific IP addresses or whatever. So in a typical solution, what you may not realize is that you're actually deploying your solution out to the public web, and even though you might have an ingress through a web app that has these keys, you maybe even put Entra ID on top of it to secure it to just your company, you still have a lot of public endpoints exposed. So what I want to do is focus in a little bit on the AI part of that, specifically if you're going to use AI search and Foundry. They're no different than these other resources. The main thing is instead of a connection string, now we're looking at an API key and an endpoint to connect to them. But if we leave them public and our API key is exposed and the endpoint is exposed, somebody could be querying my Azure OpenAI or my Azure Search, which is supposed to be private data. So I definitely don't want that to happen. So when the hacker comes along and steals my keys, they can get to my stuff. So we want to prevent that. So the easiest and immediate fix that you could do, if you find yourself in this scenario, is you could say, I am going to go home this weekend or next week, and we are going to implement policies around making sure that these Azure resources and our storage and our database and our other things like Key Vault do not use connection strings for connections. Instead, we're going to switch to Entra ID. And by doing that, we toggle off the ability to connect to them with that connection string, and only authorized applications or users should be able to connect to them. That does not prevent them from being exposed to the public. They'll still have a public endpoint, and if someone could somehow spoof that connection or log in as a compromised user, they could still get to my data. So it's not entirely secure, but it is the first step in getting rid of things like keys that got compromised. And you can do that for your AI solution as well. Instead of using the API key, use the Azure RBAC connection. So in case you're not aware of this, every application service or every service that you do at Azure can have managed identities on them. So you go to your app service or whatever you're using, container apps or whatever you're using to connect with your app, turn on the managed identity as a system managed identity, and then you authorize those credentials against the resources. And at that point, the ingress has to come in through either that app, and then it will act as that app with its credentials to connect, or through the public if you had the Entra ID and you knew how to get there. So we're still a little bit public, but we're much more locked down when we switch from using connection strings and keys. So we want to make sure we're not public at all. And the easiest and best way to do this is to create a network, a private network around those resources. So the first thing I want to talk about is a concept called peering. In case you're not aware of this, when you create networks, it is a lot better to create multiple networks and link them together than to just throw everything into one network. The same way you would do an app service with an app workload in a resource group and another app service with a different workload in a different resource group. So you get those isolation layers that you want to have. If you throw 700 resources in the same resource group and someone deletes that resource group, it's going to be a big mess. So, or just having access to the resource group as a contributor, you could modify all of those resources. So the same thing goes with networking. If we build a hub and spoke network, or just at least 2 networks to have different app workloads that need to talk to each other, we can peer them together, which makes a tunnel or a bridge for those 2 networks. And once you're ingressed into one side, then you can go bidirectionally between them, as long as you configure it the right way. So a typical deployment may look like this, where we have the hub, which is mostly for the ingress of all the outbound traffic. So you have a number of resource ways that you can get into that hub, and a lot of these subnets have to be named exactly specifically to use the right resource. So most of us in the enterprise world will find ourselves trying to connect from an on-prem into the cloud through the hub. And we'll typically do that through what's called a VPN gateway. And so that goes in the gateway subnet. And then after that, maybe we have a firewall, which might have some public IP address that comes into that firewall in the hub, and then traffic can be routed from that firewall to the specific resources in different spokes. The firewall has 2 subnets with a subnet range of 26, and so you can use them in the same, like 10.whatever.2 and 10.whatever.2, 64, so whatever 128. There's also a thing called an Azure Bastion. If you're not aware of that, the Bastion lets you connect from the portal. Now the nice thing about a Bastion is that it is a resource that ingresses into your network. It is also going to be done through the portal over 443 or SSL, so port 443, and it has to be RBAC authorized. So only the people that can log into the Azure subscription can get in through your Bastion. It is a little more expensive because it does have a backing VM, so you're actually going to have $150 or so of extra cost to do that. But if you go to the premium level with Bastion, you can actually record the screen and see who's doing what when they come in to your web. So that's a really good thing if you need a lot of traceability or accountability. And the easiest way, of course, is just create a management subnet, throw a VM in there, and you can get on the network from anywhere as long as it's got a public IP. And then on the right-hand side, we have our regional app. And that's where you'd put your app resources. So you typically want to do an app gateway if you want to expose it to the public and have a load balancer on it. So you can do that per region, or you could do a front door and direct it to either traffic, to either network. For ease, if you want to just get started, you could still leave the web app as public ingress only, and then expose everything else only privately inside the network. That's the easiest way to get going. You can segregate by subnets. I have a function subnet, a web subnet, and an endpoint subnet here. You have to have certain subnets to do certain integrations. So if I'm going to have a durable functions app, I need a functions subnet which has a delegation to the container app service, so Microsoft.apps. And if I have a web subnet, that's for my app service to also have the Microsoft Server Farms integration or delegation. That just means that those resources can actually talk inside of my network on their outbound traffic, but they have to be on their own subnets for that. For the endpoints, you can choose how you want to do it. You can put your endpoints in the same subnets, like the endpoint subnet here, and that has everything in one place, which is an easy way to do it, but you lose a little bit of control if you do that. So a lot of times for a more deep enterprise deployment, I'll do an endpoint per resource type. So I might do a vault subnet, I might do a storage subnet, and just have their endpoints in there, just so I can route my traffic only specifically for those services and keep them composed in those. So I already talked a little bit about this. This is as far as we're going to go with this, but this is essentially how you connect into the hub, different ways to connect via those subnets. And again, you have the VPN gateway, which most of us will use. There is also an express route, which is the private route that goes, it's basically a fiber connection between buildings. The advantage to that is you don't have any public traffic egress at all. With the VPN, you're over the public, but it is encrypted. But if you go with the express route, it's going to go building to building, private tunnel, no encryption, super fast, a little more expensive. So just keep that in mind, depending on your enterprise, what you want to do there. The other thing I want to really ask you to do is don't do ClickOps. Just don't do it. At this point, we don't have any excuses to not use infrastructure as code. Whether it's Terraform or Bicep or Pulumi or whatever the flavor you want to do is, great. I don't care which one you use, but I work for so many clients where I come in and they have done ClickOps and certain things have happened or certain things go wrong, or we move something from one region, East US to West US or Central US, and we forget to do one little setting. And that one little setting causes downtime or pain or frustration for us for hours, which is something that we could have overcome if we just would have had infrastructure as code. So again, I don't have a lot of time to go into everything today with the infrastructure as code. I do hope to get some of that out there for you in a repo at some point, and I'll put that on the link that you'll see at the end again as well. So if you check back maybe in a month or so, there might be more there. But for that reason, I will say this. There's no reason if you have Claude or Copilot or any other tool, even ChatGPT, you could go tonight or whenever you want to, maybe not on a Friday night, but you could go and you could say, I would like to have this deployment. And you could say, please generate the bicep for me. And you will be amazed at the number of things it will do. Now, it's not going to be perfect. You're going to need to oversee it because it will not parameterize anything unless you ask it to. And you're going to want parameters, especially if you're going to do a dev deployment and a production deployment. And you'll have to tell it how you want to name things. So I specifically like to name my resources by the thing that you get off the periodic table, which is like app for an app service, ASP for an app service plan. You go out there, you look at the Azure periodic table. If you're not aware of that, just type it in, you'll find it. And it has all of the naming conventions you should use to keep things standard. And so ultimately then you use that, use the name of the app, so something like Secure AI, the region, so maybe Central US, I give an abbreviation like CUS, and then the environment, dev or prod. And then I know exactly where the resource is deployed, what region it's in, and what its workload is supposed to be, just by looking at the name. So if you train your agent or ChatGPT to name your resources as that, ask it to generate the bicep, you'll be very happy to see all of that getting generated. As was mentioned in an earlier talk today, if you do storage accounts, remember 3 to 24 characters only, all lowercase and numbers only, no dashes, no uppercases. You wouldn't want that to break your deployment, but it will happen because everybody does it. So ultimately, leverage your AI, give yourself a tool like a Bicep Architect, and build out your services. Do them in a modular way. So don't try to make one giant deployment. You're going to want to do multiple storage accounts. You're going to want to do multiple function apps. You're going to want to do multiple app service plans. So separate everything, including things as little as the event grid events that you want to wire up, or the function app components that you want, or maybe even Log Analytics Workspace and Azure Application Insights as their own files. And then you can use your deploy all orchestrator to get the resources deployed exactly how you want to with dependencies, and put parameters in place so that you can use that. So the really good thing about putting your stuff into Bicep is that it becomes very easy to deploy with something like GitHub Actions. So I'm hopeful that most of you have seen GitHub Actions at this point, but I will briefly talk about what that takes to get wired up with my account. So in case you haven't, you'll know. So at the end of the day, I told you already that if you put an app service into managed identity, it gets a system managed identity, and that is one-to-one with that resource. So that app service can be directly identified by that managed identity. But what I want to do is I want to create 2 managed identities that I can use for multiple deployments. So what I'm going to do is I'm going to create 2 user managed identities. Now the difference between a user managed identity and a system managed identity is the user managed identity is reusable for multiple resources. So if I need to have a fleet of VMs or a fleet of app services with the same security settings, I can use that user managed identity to give them their authorization, and then all of them that are associated with that would work. The same thing goes for the deployment. So I typically create 2. I don't want to have everything under one hood. So I need one to do the actual resource deployments and another one to do the permissions assignments. So I don't want to give them both. Otherwise, that's too much power. I might as well have given them owner, at which case you know that's way too much. That's like God mode, and we don't want to do that. So each of those will be on the same subscription, the same tenant. So ultimately you need 4 secrets, 2 client IDs, one for the user authorized agent, and one for the deployment, managed identity, sorry. When you go out to the managed identity, you need to add federated credentials, which include your GitHub organization, your repository, and either the environment or the branch that you want to deploy from. That's the handshake. So Azure needs to say, you know enough to get in here, but I'm not going to let you in unless you also match certain settings. That's the federated credentials. So if you're not coming from the right repo or the right organization and you still have all my keys, you still can't deploy because I won't handshake with you unless you match on the federated credentials as well. Give the one managed identity RBAC contributor so it can do resources against the subscription and deploy on the subscription. And then give the user access administrator, you can either choose to deploy at the subscription level or the resource group level, but the user roles will definitely be scoped into your resource itself, resource group, excuse me. So you'll want to just probably give that resource group only, which also gives it least privilege. So this is what it looks like to create a user managed identity at Azure. You go out, you say, I'd like a managed identity. You give it the resource group and the region and the scope you want. You can do regional scope if you want to only deploy to a specific region from that group, or from that identity, excuse me, and give it the name you want. Then you add the federated credentials, and this is the important part. I'm sorry that's a little small up there, but ultimately that GitHub ID is your organization. The repository is the repository that you're coming from, and then you choose whether you want the environment and dev, which is what I like to do, set up environments, dev and prod, then they can't accidentally deploy the resources thing to the wrong subscription. So if I have a dev subscription and a prod subscription and I try to run my prod deployment against my dev subscription, it'll automatically fail by federated credentials. So I can't accidentally do that, and I can't accidentally deploy dev subscription into prod. And that's a good thing. If you use branch, then what ends up happening is you typically say something like branch main. Like if we push to main, we're going to build this thing and we're going to deploy it. The problem with that is there's no segregation of environments, and you can still do this, but you could push dev code into prod if you have the same credential and it's all wired up correctly. So that, you could do a separate credential in your other subscription and that would be good too. But that's basically the difference between those two. So you go out, you get the credentials off of the managed identity, which is the client ID, the subscription ID, the tenant ID. You add the permissions to the different identities in the Azure IAM blade. You say, I would like to add the role assignment of privileged administrator of contributor or user access administrator, whichever one you're trying to add for whichever role, and then you grab the managed identity you want to map to. This one is the one I named contributor, so it's getting contributor permission. And then ultimately you have your Azure side set up. Then you need to go out to GitHub, go to the repository, and create secrets on your repo. Those secrets include those 3 values that you needed to know for the client ID, the subscription ID, and the tenant for the deployments. And then I added the 4th one here, which is the user access administrator client ID. So I could use that one from a different workflow to do my permissions assignments. So you end up with 2 workflows, one that does the deployments and one that does the assignment of permissions after the deployments are done. You create a workflow. It's very easy to do. You make sure you map. If you're using a federated credential, that's what that environment dev is doing. You have your client ID, tenant ID, and your subscription ID that gives the login permission for the Azure login action. And then ultimately, whatever you're deploying here, this is deploying my bicep files. So it says deploy all and run with deploy all the bicep parameters, and then tags the deployment with architecture and a GitHub run number. So it's individual deployments showing up under my subscription in Azure. And it's always green, right? Nobody ever sees red on a pipeline, right? Yeah, okay.
Wait a minute.
You're doing it wrong.
That's my fault. User error.
User error. All right, so now we come to probably one of the most tricky, confusing parts of this entire scenario. So we've started, we're gonna make everything private. We've got our bicep in place. We've got our hub and our spoke and all the peer stuff in place. We're ready to start setting things up for our applications. And so which do we use, service endpoints or private endpoints? And this is where a lot of us get kind of messed up in the head. We're like, I don't know. What are we doing here? So let me just talk to you briefly about the two and when you might use one or the other. So let's start with service endpoints. Service endpoints are easier. They're assigned at the subnet level, and they will let you connect to anything from that resource. So if I want to have outbound traffic from my web app to a storage account, I can add a service account or service endpoint to storage, and then I can connect to storage. That still stays as a private. It still stays as a private route, but it's on the Microsoft. It's on the Microsoft network when you do that. It's not completely private. It does leave your tunnel, so it goes out over the public a little bit, but it's the Microsoft managed public, so it's not like it's supposedly hackable. But when you do this, your service endpoints don't cost anything extra, so they're also cheaper. So not only are they easier to implement, they're cheaper. But there are some drawbacks. So the drawbacks to this are, and I like to talk about robbing a bank. So if I was to be a corporation like Wells Fargo, and I have 30 banks in the Eastern Seaboard or whatever, I have 30 different points of exposure that could be robbed. So the attacker could, or the robber, could go to one in New York and rob it, or they could go to one in West Virginia and rob it, wherever they decide. And all of those are banks that are exposed to their public attack. When I do a private endpoint, it's like I only have one bank that's exposed. And it's not even exposed. It's like Fort Knox. It has a private security around it that the only way in is to come in through already being in my network. So if you want to think of it that way, private endpoints are going to be a little more secure. Private endpoints are also more expensive, about $7 per month per resource. But that means that one single endpoint goes to one resource. Oh, and I forgot to say one thing about service endpoints. You can put restrictions on service endpoints. You can say, this service endpoint only connects to this storage account, no others. And that's fine, but it's, again, more extra stuff that you have to implement. With the private endpoint, you're basically going to get a private IP address directly in your network that points to that resource. So now I'm able to say, I want to go to 10.0.40.7, and that's this specific storage account only, and no other storage accounts. And it's a private tunnel, like a secret passage, that you have to be already on one side and know how to unlock the secret passage to get through to get to that storage. It's not exposed to the public at all. So the other thing is, with the private endpoints, you also have two other resources, and they have to be configured correctly or it won't work. The first one is a DNS zone. It's a private DNS zone, and if you put that in your spoke so that your spoke traffic can talk to each other, which is what you want to do, you may need to replicate that in your hub. If you're coming in from the hub, you might have to have the same routes set up in private DNS zones there as well, so it knows that mystorage.azurewebsites.com is not 292. Whatever, it's actually 10.0.7 or whatever. So those DNS routing makes sure that it knows how to resolve. So your developers still use the same public endpoint, but it comes in and it says, oh, that's actually this private IP, and it never leaves your network traffic. The other thing is that means if you need to be NIST compliant or some of those more strict security things like HIPPA, potentially GDPR, other ones, you're now in a situation where you can log and monitor every single piece of traffic that goes between these. So it's much more secure. It gives you more auditability on those resources. Again, more expensive though, $7 a month per endpoint. So this is what Microsoft gives us when they say, hey, this is what this should look like. You probably have an application gateway that lets your public traffic in. You have the NIC that comes along with it, with the private endpoint and the DNS zones. And that routes to these different things. What's most important to understand is that when I create an app service or a storage account or an Azure AI instance, those aren't in my network at all, ever. They are never part of my network. If I do a VM or an appliance like a firewall, those actually get deployed into my network at Azure. So if I delete my network, those things go away. But an app service lives on an Azure managed or a Microsoft managed public backbone. And so in order to connect to that, I need that private endpoint to connect to it. And so the private endpoint puts a NIC in my resource, in my network, in the specific subnet that says, I actually point to this public, or this Azure public resource, which is now all private. Only this route comes to me. So that's what's going on here. The private DNS zone resolves the traffic, and all of those past services just live in a situation where they're still deployed by Azure on their servers just like they would have been, but now only the traffic through your network gets to them. Here's the biggest problem. Once you are deploying your resource and you've made it private, now your GitHub action fails. GitHub can't talk to a private resource because GitHub's not in your network. So how do we get around that? Well, basically, we can do a couple of different things. Private GitHub runners, which requires an enterprise account. And what that does is says, yes, I can run from GitHub with this private runner connected to my network, which is a pretty nice solution if you've got GitHub Enterprise and the ability to afford that kind of thing. The other thing you can do is you could just put a management subnet in your spoke and do a management VM that's private, that lives in the network already, that can run the GitHub actions through that private deployment. Also expensive, another $150 a month or so to deploy a VM into your resource group, or into your region, sorry. There's another way, container instances. I tried to do this, I punted on it. It's extremely difficult, but there is an image out there that runs GitHub Actions. You could try to spin up a container instance and just run it on demand, but there's a lot of pain points with that, so I punted. If you figure out how to do it, I would love to see that in action someday. And then there's the cheap hack that Microsoft released in 2021 on a blog post. It's the most hackiest thing ever, but it works perfectly. And what ends up happening there is we're going to end up having a connection to this storage account public through a SaaS for just a few minutes. So this is just a diagram that shows, you could be in the network and you could deploy. But this other way that you could do this is you create a script and a storage account. And the storage account gets a SaaS token that's exposing the way to write blobs to that storage account for about 10 minutes. And for that 10 minutes, you'll have this public storage account where I've deployed my resources. So I publish from the GitHub action as a package into that storage account. And then that storage account can be reached from my network. And then we do an AZ web deploy on that action. And it gets it out of the storage account, puts it into your web account, and destroys the storage account. So there's about a 10-minute window where there is a somewhat public storage account. If someone had my SaaS token, they could potentially get my code. That's the caveat. But who's going to have your SaaS token within 10 minutes? Well, we still have to plan for that, right? So just know that that's one of the things that's the biggest drawback with that. And that looks a little bit like this. You still have everything in GitHub just like you had. You still have everything in Azure just like you had. You just have the extra storage account with the SaaS token that runs that script. The other gotcha, this one has bitten me hard, is when you have a private function, an Azure Functions instant, and it's trying to be triggered by a blob drop into storage. So you typically do that either with a blob created event on the Azure function or an event grid trigger. Event grid triggers are my favorite. They're just a little bit better to control and have things around. But the problem is that a private Azure function doesn't expose any public access. The event grid cannot hit your Azure function when it's private. So you drop a file in storage, everything looks like it's working, you're getting 0 logs from your Azure function because it never got triggered. You're getting a delivery failed event from the event grid because it says, I can't deliver this thing. And what's even worse is that delivery failed event might be because the Azure function didn't start. It might not be because it couldn't reach it. It might just have like a 500 on startup. Maybe the connection string's wrong to the database, and so this function app didn't run. So you've got to kind of make sure you know your function app is working, then try to hook up the event grid. And if you still see it's not working, the first thing you should think is, oh, my event grid can't hit this. So what do I need to do? You go to the Azure function and you turn on a service endpoint for Azure Event Grid to that Azure function. And that's kind of what you see down here. It's basically saying event grid can hit this thing. So hopefully you guys can see that good enough. If you look at your function, then it tells you, I have one private endpoint, but I'm also enabled with access restrictions. So the public is enabled, but only to event grid. Now event grid can trigger my function, and the only way my app can talk to the function, if I want to trigger an HTTPS endpoint from my app is via a private endpoint still. So the public is still blocked, but that event grid event can trigger. So that's a huge gotcha. It's cost me hours that I want back, but I can't get. All right, so let's kind of bring this thing towards home, and let's talk about now we want to do an AI workload into this. So we've got our network secure, we've got everything wired up, all our endpoints are in place, everything's talking, Azure's triggered. I want to drop a document into storage. I want it to run an Azure function that then ingests that data into search so that I can then have a web app which goes out and grabs the data from search when a user asks a question. This is probably the most basic, typical workflow you'll build for a lot of companies. And ultimately, there are two ways to do data in Azure Search. The first way is you can have Azure Search build the index and crack your documents itself. This is kind of like, I don't want to do any extra work. It will work, but you lose a little bit of control when you do this. So a couple of problems I've run into when I've done that before is, number one, the chunking or cracking that happens in that case is completely under the control of all of Microsoft's hood. If they decide to change how search ingests data, I have no way to prevent them from doing that. Now, I'm not saying they would do that. I don't even know what that means, honestly, if that would break things or not. But if they did change it somehow, I would not be able to stop them. And I'm not saying we're trying to stop Microsoft. That came out wrong. But I'm trying to say we're under the domain of however they decide to ingest it. The other thing is, if you have large documents, bigger than a certain number of megabytes, it won't ingest it unless you go to a higher tier. So now you're going to pay more money for Azure Search. The basic search tier is about $75 a month, a couple dollars a day, totally worth it if you could stay on that. But when you get up to $300 a month now, just because one of my documents was 500 megabytes, suddenly that's a whole different conversation with your boss and figuring out, do we really want to do this? So if you're a developer and you have access to AI, I would highly recommend chunking your own data and using your Azure function to publish that data into your index. So you still create an index at Azure Search, just like you would have done with the cracking and ingestion, but now you're in control of how many chunks you want. And you're doing this with C# or Java or whatever choice of language you use. But if you don't understand how to write cosine angles, like I don't, or whatever it is to do the vector embeddings that needs to go into Azure Search Index, then that's where AI can be our really good friend. And again, at that point, we are trusting AI a little bit, so maybe it's not as safe as it sounds, but it is a nice way to say, I have full control over how my data is chunked, how it overlaps, and how I push that into the index as soon as someone drops a document. And so that's basically what's going there. So ingest your data, index your own code, index with an indexer or your own code. If you use Azure, you do have to give the Azure Search Indexer a text split skill. If you use your own code, you need to deploy an additional model. So in your AI instance, you'll have an OpenAI model of choice like ChatGPT-5 or Claude or whatever. And then you'll also have the text embeddings model. So typically like text embedding small. It's a very cheap model, but it will let you crack your data using that model. So there are two flows then as a developer that I can interact with search. So the first one is called what I'm calling direct to search. And this is actually the way that I would recommend it. I implemented the on your data flow, which I'll talk about next, last year in a project, and it works. It just seems a little bit less robust, and there's a lot more constraint around it. So I recommend, if you can, to do the direct to search and then get your top chunks from search and then send it to OpenAI yourself. So what I'm saying is the user asks a question, the questions gets sent directly to search. Search uses the embeddings in your index to determine what are my top 5 or 3 results. It then sends them back to your code. Your code then says, hey, here are the top 3 or 5 results. Send that to OpenAI. OpenAI then says, here's your response to the user. So what you can see here is there's numerous calls across your network to do this. So this is the one drawback. Now I'm saying I got a call to search, I got to get this back, I got to call to OpenAI, I got to redirect, so we have some network latency issues here. If you want to do a direct call where you only have one call, that's going to be on your data. The other pros with the direct is the interchangeable components. So you're able to say, I just decided I want to change how I write my data to OpenAI. It's different now. Or I can do additional custom filtering. I got 6 or 7 results back from search, but but I know I don't want to show this one, so I'm going to put a rule in my code that literally says don't send this part or don't send these things. And now I have a little more control over what gets formulated coming back from search before it ever gets formulated to be shown to the user. Again, there's more code here, so now I've got to manage the different code pieces that let me be able to work against that data. And there's individual points of failure. If my call to search fails, it's done. If my call to OpenAI fails, it's done. If I can't communicate back to the web app, it's done. So there's multiple points of failure here as well. So flow number 2 is on your data. So this one's the same exact flow. The only difference here is that the user asks a question, it goes directly to the LLM. The LLM sends it to search sends back data. The LLM formats it and sends it back to your app. So it's only one network call out to the LLM. The LLM talks to search back to you. So there's less latency. It's much simpler to implement. It's basically like one 30-line method, and you could have that entirely implemented. Again, it's Microsoft managed at that point. Microsoft managed how those two communicate. So you get a black box around that. You have no inspection of the chunks. You can't put additional rules or filtering on it. You get less control over the prompt construction and retrieval tuning between LLM and the search, because it's basically saying, hey, you want this? I'm going to send this prompt to search, and this is what you're going to get back. It's harder to debug because it does go into this process of like the void, and you can't determine where your failure is happening. Is it the prompt? Is it the chunks coming back from search? Who knows? We're not getting the right data when you ask the question. Or we're getting different data every time you ask the same question, which is even more annoying than getting the wrong answer. And again, it's tied to Azure OpenAI choices. So there's one last gotcha if you do decide to do on your data, and that is, again, Azure AI and Azure Search are not in your network. So outbound traffic from search can't talk to your Azure OpenAI if your Azure OpenAI is private. So you need to do what's called a shared private endpoint from search. So you add that into your search, and now they'll be able to talk to each other and be able to communicate. So if you're going to do that, you also need a managed identity on your search service so that you can give it permissions to talk to your OpenAI as the OpenAI Cognitive Services OpenAI user role. So this is just a little, I hacked a demo together to make it work. So I asked it a question. I said, what 3 actions should I take today? It gave me back my formulated answers, and it gave me my sources. So this is the other thing that is really nice about chunking your own data. The sources are better. So if I use Azure's on your data, it's going to send me back the sources it came from, but it's not as easily configured. It's much harder to determine exactly what page from the document that source came from. With chunking your own data, you can actually have that as part of your index and make sure that you send the page numbers as you chunk it. And then it's very easy to see, I got this information from this document on page 17, which is very much something your users like. So I asked it, is there a guarantee that I'll get into heaven? No takesies, backsies. And it says, I must remind you that I am an AI tool. I cannot guarantee 100% accuracy regarding complex or spiritual matters, and some other things. So basically what I did here was I created a document with a bunch of rules that said, if the user does these things, tell them this, no matter what. And so this is kind of like a guard. It's not a catch-all. I mean, how would you know someone's going to say takesies, backsies, right? So ultimately what this does, I did this rules for responses, and if it says takesies, backsies, tell them you can't answer it. And also, if they try to press you into a corner, just some basic rules there. But that's basically it for this talk. So again, this is the link. Make your deployment private. Use RBAC instead of keys. Make sure you're using your resources and permissions correctly. Ground your data with search. This is how you can connect with me. I'm Brian at Major Guidance Solutions or blgorman@gmail. I'm on Twixter at blgorman, LinkedIn, Brian L. Gorman. And then finally, if you want to support me, you can listen to my music on Spotify. It is Christian music, so if you're interested in that, it's out there. Also, I had written Practical Entity Framework Core 10, which came out at the end of last year, so that's out there as well if you're interested in that. But thank you very much for having me, and enjoy your movie.